Hi, welcome to my video on extra problems number 2. And I decided to do another video on some problems because, again, the more problems we do, the better we understand. Hopefully, the more we'll get right. Number 1, a right triangle has a volume of 160 pi cubic centimeters and a height of 10 centimeters. To the nearest degree, find the measure of the angle formed by the diagonal and the base. Well, it says we have a right cylinder, so let's draw a right cylinder. Right cylinder, and this is what we can't see, and this is the top of the cylinder. Okay, and it says it has a volume of 160 pi centimeters cubes, and it says that the height h is 10 centimeters, and it says to the nearest degree find the measure of the angle formed by the diagonal and the base. Well, the base is the bottom of the cylinder down here. The diagonal is a segment drawn from the top through, passing through the center and hitting the bottom. So there's the diagonal. It leaves a point the point that's on the top of the circle, joining a point on the circle. So this diagonal is a segment that passes through the center of the cylinder. And as a result, we want to find the angle between the diagonal and the base. So the angle between the diagonal and the base is, let's draw this. This is the diameter here. So this is the angle that I want to find, this angle right here. So how do we go about doing that? Well, we have a volume, and we have the volume of a cylinder. Volume is pi r squared h. And as a result, well, just before we do that, the cylinder it's a right cylinder, so we have a right angle. So the volume is 160 pi. And we have pi r squared, and the height is 10. So we simplify the right side, we get 10 pi r squared. So we cancel the 10 pi on each side. Pi's cancel out. So 10 divided by, that's a 60, equals r squared. So the square root of r squared is plus minus the square root of 16. So the radius is plus minus 4. Well, we know that the radius always has to be positive. So if the radius is positive, if the radius is 4, the diameter is twice the radius. So the radius is 4, so the diameter is 8. So this is the base, so the diameter moves from the longest chord that's in a circle. So this diameter here is 8, and the height is 10. So we have a right triangle, and the diagonal of the cylinder forms the hypotenuse of a triangle. So we want to find this angle right here. So I'm going to call this angle A, B, C. So that's the angle I want to find. The angle ABC is what I'm going to call X. So we have a right triangle, so we can use SOHCAHTOA. SOHCAHTOA. And in this right triangle, in relation to this angle X, this is the opposite side, and this is the adjacent side, and this is the hypotenuse. So we have opposite and adjacent, so that's tan. So the tan is opposite over adjacent. So the tan of x opposite is 10 divided by 8. So angle x is tan to the negative 1 of 10 divided by 8. And that comes out to be 51.3 degrees if you use your calculator. And so the answer says to the nearest degree is 51 degrees. Again, a review of the trig, and we have a diagram. I just made up this one day. So we have a cylinder, and we reviewed in previous trig units on the right triangle, and solving, we went over the diagram of a cylinder, and in the volume of a cylinder, we went over what the diagram was. So I just wanted to bring that back in. Now, don't forget, we can pause the video at any time and work these out before I do. That's the beauty of having it on YouTube and videos. You can pause the video and work out your answers, and then go back and see if you have it right when mine play through. Okay, find the area to the nearest square meter of a regular octagon whose perimeter is 48 meters. So let's see, we want to find the area of a regular. Now, a regular octagon. So a regular octagon has 8 sides. And the word regular means all angles and all sides are equal. All angles are the same sides, and all angles are the same measure, and all sides are the same measure. So let's see, we have a perimeter P. I'm going to call P for perimeter. The perimeter is 48 meters. So that means if you take your perimeter is equal to the number of sides, S, times it's 8 is the number of sides, and S is the length. So if your perimeter is 48 and you have 8 sides, you want to find the length of each side. We divide by 8, and S comes out to be 6. So let's draw an octagon. An octagon, let's see. We have one side, and try to draw them the same length now. 2, 3, 4. Do the same thing as a mirror image. And pretend that what I've drawn here freehand is an octagon. So an octagon has 8 sides. As a result, if you draw the diagonals like this, and they all go to the middle. So all these there are more diagonals because this is a diagonal and this one is a diagonal, but these diagonals all meet in the middle and they form 8 triangles. And because all these sides are all equal, like this, all these angles are also equal. So we got 8 triangles, we got 8 equal sides and 8 equal angles. So what happens, the angles of around this center here forms 360 degrees. And if we have 8 triangles, and each triangle is equal in area, then we have 8 angles. So that means that each angle is 45 degrees. So let me take one triangle out of that. So this is one triangle, and we know that all these sides in here, all these triangles are congruent because it's regular, like that. So that means that side and that side are equal. And this is the perimeter. This is the side that makes up the perimeter. So this triangle here is, if you name that O, A, B, and I go make it larger, OAB. So we have this angle OAB is 45 degrees. And the side of this is 6 here. And these are equal. Notice we have an isosceles triangle. And as a result, we have 180 minus the 45, which gives us 135 degrees. And if you take the 135 and divide it by 2, you get 67.5 degrees. So that means this angle here is 67.5. This angle right here is 67.5. So now, if we want to get the area of the triangle, if we can find the length of this side, we can use half of the two sides and included angle. So to get the length of this side, I have 3 angles and 1 side, so I can use the sine law. So the sine of 45 over 6 is the sine of 67.5. Let's call this x. And so x turns out to be 6 sine 67.5 degrees over sine 45. And if you sub that into your calculator, then you'll come out to be 7.84. And that's the length of that side, 7.84. Now, to get the area of that triangle, we can also, the area of the triangle is a half the two sides, which we say AB sine theta. So that's a half of 6. And this side right here is 7.84 sine of the angle in between, 67.5. And when you put that in your calculator and work it all out, you'll come out to be 21.7. Now, but we have 8 triangles, so the area of the octagon is 8 times 21.7, because there's 8 equal triangles, and that brings us up to 173.6, and the length is in meters, but the area is in square meters. So 173.6 square meters is the area of the octagon. And while I'm at it, I could also, what about somebody looked at, let's draw this triangle again. What about somebody said, well, this is 6, and we have a 45-degree angle right here, and these two sides are equal. Well, we learned that if you drop a perpendicular down between these two equal sides, it bisects the base, or this opposite side, into 2 equal segments, 3 and 3. And it also bisects the angle here. So this angle here becomes 22.5, and this angle right here becomes 22.5. And we know that this angle is 67.5, and we know this angle is 67.5. So, if we could get this height here, which I'm going to call y, I have a right triangle now. So this right triangle, which is this one, I can use SOHCAHTOA. If I spell it right, SOHCAHTOA. Just got sidetracked there. SOHCAHTOA. And this is the angle that I have in this right triangle. So this is the opposite side, and this is the adjacent side. So the tan is opposite over adjacent. So the tan of 67.5 degrees is opposite, which is the y, over the adjacent, which is the 3. And cross multiply, y equals 3 tan 67.5. And y comes out to be, what, this one is, y comes out to be 7.2 when you multiply that with a calculator. And so the area of one triangle in this one is half the base times the height. And the base of the triangle is 6. And y is the height, which is 7.2. And if you multiply that out, you get 21.7, same as this. And then you multiply by 8, and you get the same area. So you could have did the area, you could have did the side like this and used the area of a half AB sine theta, or you could have got the area of the triangle using splitting this because of the altitude drop down, and you could have did it two ways. Either one would be suffice. Okay, let's continue. Number 3, we have a triangle. As you can see, we have x squared plus x plus 4 and 3x are the lengths of these sides. And it says that FH add on HJ equals 9. The area is 4.5. Find the measure of H. Well, we have an area, and when I think of area, I think of an area of a triangle as we don't have any right triangles, so I think of the area as a half of AB sine theta. So theta could be, if you want to mark that, theta could be this angle right here. And these are the two sides. But how do I get numbers for these? Well, it says that FH plus HJ is equal to 9. So FH is x squared plus x plus 4. There it is. Add on HJ, which is 3x, and that adds up to be 9. So we simplify the left side, x squared plus 4x plus 4 equals 9. We got a quadratic. Quadratic has two factors, or two roots. So x squared plus 4x plus 4 minus 9 equals 0. So we let the quadratic equation equals 0. X squared plus 4x minus 5 equals 0. And a quadratic has two factors, two roots. So let's see if we can factor this. This is easy. In one way, it's easy. For me, x squared is x times x. The product is negative 5, so that's a 5 and a 1. So the first gives you x squared out. The last gives you 5. And you have a negative product, so it must be a plus and a minus. So since the product is negative and the sum is positive, I must have a positive 5 and a minus 1. That means x plus 5 equals 0, or x minus 1 equals 0. I just want to get back to this. If you did the FOIL on this, you get an x squared minus x plus 5x minus 5, and negative 1 and a plus 5 gives you the 4 in the middle. Okay, back to this. One answer is negative 5, and the other answer is 1. But we have a x is equal to negative 5. So if you take j, hj, and say 3x, then 3 times negative 5 is negative 15. So that means negative 5 can't be used. So if I use x is 1, then hj is 3x, x is 1, so hj is 3. And now we have, let's see, hf is equal to x squared plus x plus 4. So that's 1 squared plus 1 plus 4. So we square, and then we add after. So that's a 6. So this side here becomes 3. This side here becomes 6. So we want to find this angle theta, or h. So we have the area. So the area is a half AB sine theta. So the area that we're given is 4.5. It's a half of A, which say 6, B is 3, and it's the sine of theta, but theta is also the h, so we can say theta or h here, makes no difference, because we said that theta was this angle h, and h is what we're trying to find. So we got 4.5, half of 6 is 3, so that's 9h, 9 sine h, so we divide by 9, so sine h is equal to, that looks like a half, so angle h, if you divide by the calculator you get a 0.5, so that's h is sine to the negative 1 on the 1/2 or 0.5, and if you use your calculator, a half gives you an angle of 30 degrees in the special right triangle with a calculator. And so the measure of this angle is 30 degrees. Again, wanted to do this one. I also wanted to enter a problem where you had a quadratic, where you get two answers, and one of them is not usable here. I made it up, designed to be that way. Always helping you think. Now, we end off with this last one. And we have a triangle which has sides of 10 and 15, x, and the angle is theta. It says the sine of theta is 3/5, and we got a pi over 2 less than theta less than pi. And we want to find x to the nearest 10. X is the length of the side. Well, let's look at sine. What we have is pi over 2. We got it in radians. So pi over 2 is 180 divided by 2, so that's a 90. Theta, pi is 180. So what we have is that we have we have a circle. So this theta lies between 90 and 180, lies between, this theta lies in here. So also sine, add sugar to coffee, sine is positive in 1 and 2. So if sine is in quadrants 1 and 2, and right here 90 to 180 is in quadrants 2 and 3, so the overlapping quadrant is 2. So if we draw a terminal arm in 2 right here, like that, and so this angle we're talking about is right here. So I'm going to do this two ways. If sine theta is 3/5, I have a choice. I can say that, what about if I did that? Let's use the calculator and go inverse sine here. Let's use the calculator to get what theta is. Theta is equal to sine to the negative 1 and 3/5. So theta is, and turn on the calculator, clear it. So inverse sine on 3 division 5. So that angle is 36.87. 36.87. So this angle, that's 36.87, if you want to, degrees. If that was it, that's in the first quadrant, because that's your reference angle, 36.87. Therefore, to be in the second quadrant, what happens, that's one of the angles, but we want it in the second one. So really, theta is going to be 180 minus 36.87. So theta, which is in the second quadrant, mark that second quadrant, is, I'm going to go 180, subtract, and I pick up my answer. Whoop, I'm not showing you what I'm doing here. I'm going 180, clear that. I'm going 180, subtract 36.87, and that gives me my angle is 143 point, I could say 143 degrees, but I'm just going to two decimal places to be just a little bit more accurate. So that means I found the angle that I want to use. So this angle right here is 143.13. Not because the triangle is drawn obtuse. I could have given you this information without drawing the triangle. So if I got two sides that include an angle, I can't use SOHCAHTOA because I have no right angle. I can't use the sine law because I don't have an angle in the side. I got a side, no angle. I got a side, no angle. I got an angle but no side. I got to use the cosine law. C squared is A, oops, sorry about that. Let me make it small. A squared plus B squared minus 2AB cos C. So this angle theta, C is going to be, this is the C, that's the angle C, this is the small c. So we put x there. A is 10, B is 12, minus 2, 10, 12, cos of 143.13. Now you can, if you plugged all that in your calculator, but we can take our time and work it out if you want, or we can plug it all in, either or, whatever you want to do. And but when you do, x squared is, I can work it out and get 215, and I'm going to sub all that in the calculator. So I'm going to say it's -2. Just move this up a bit so you can see it. It's a, just have a negative. Oh, I got the answer coming. See? I'm going to do it without the. So if I plugged it all in, then it wouldn't say the answer, because if I hit that now, if I go 2 times 10 times 15 cos of 143.13. Notice that gives me, I didn't put the negative in, so that's the negative of -239.999. So that's close to 240. So that's 100 plus 225 plus 240. That adds up to 565. So the square root of x squared is plus minus the square root of 565. So x is equal to plus or minus 23.77. You check with your calculator. And now remember, you can plug it all in. And now in a minute I'll sub it in. And the answer is going to be positive 23.77. And so the answer to the nearest tenth is 23.8. So what I want to do is plug all this in the calculator now for you and show you that when I sub all this in correctly, I will get, notice that the cos of a -240 is negative, and a negative of a negative makes it a positive. Now if you sub it in the calculator, it'll just give you this, but this is what's happening. But when you work it out separately, the negative makes it positive. So I'm going to sub all that in now. So here we go. Here we go. Sub it all in clear. I got, let's see, I'm using my 10 squared plus 15 squared, subtract 2, I'm going to say bracket 10, bracket 15, and cos of 143.13. Now I'm going to hit enter, and I get 564.5.99, which is 5. So 565. Now I'm going to go second function, inverse. I'm going to pick up that answer without typing it in. And I get 23 point, as you can see, 23.8. 23.77, 23.8. So, just wanted to show you how to manipulate the calculator. When you sub all this in your calculator, that's a subtraction sign. And don't forget the brackets around the 10 and the 15, and it works out to be 565 without manipulating all this with a pen. So that brings us to the end of the video on second set of word problems in this unit. And if you like it, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel. Thank you for viewing my video. Bye-bye.